friends, welcome to my channel. So in the today's lecture, we are going to discuss optimal page replacement algorithm. Okay, optimal page replacement algorithm. Till now, we have discussed first come, first serve and least recently used page replacement algorithm. Okay, I will mention the link of these two videos in the description box. Okay, so what happens in this optimal page replacement algorithm? Okay, it is the most effective algorithm out of all of the other page replacement algorithms. Okay, in this optimal page replacement algorithm, we try to determine the future. Okay, we try to determine the future. So, let me give you one example. Okay, let's suppose you want to achieve some goal. Okay, you are going to make plan of your future. Okay, you decided that within 1 year I will achieve this goal. Okay, after achieving this goal, after 5 years I will be achieving this goal. Okay, this is your first goal, this is your second goal. And you have planned that after 10 years I will be achieving this goal. Okay, so you are making planning of your future. Okay, but now which is most important goal for you? Okay, we always prefer to live in the present. So now I will firstly focus on the goal which I decided to do in the 1 year. Okay, now I am not going to think about the goal which I have decided for the 10 years, which I have decided to do after 10 years. Now I am firstly focusing on the goal which I want to achieve within a year. Okay, after achieving this goal, I will be focusing on this goal. Okay, so now which is the most important? At this point in the present, I will not be focusing on the goal which I want to achieve after 10 years. I will be focusing on the goal which I decided for the near future. So in optimal page replacement algorithm, we focus on the near future. Okay? We don't give preference to the goals which I want to achieve. Okay? At a later point of time, which is very far in the future. Okay? So that is actually my optimal page replacement algorithm. What page replacement algorithm says? You focus on the near future. Okay, so let me give you one example so that you can understand it better. So let's suppose your CPU is executing process P1. Okay, your CPU is executing process P1. And I have allocated 3 frames to process P1 in the main memory. Okay, so your CPU firstly requests for page number 4. Initially there is no page present in the main memory. All these 3 frames are vacant. Okay, so your CPU is requesting for page number 4. We will get page fault. Okay, because your page 4 is not present in the main memory. So we have to load this page 4 from hard disk to main memory. Okay, so I am loading this 4 page of process P1 in main memory. Next, your CPU is requesting for page 7. Page 7 is also not present in the main memory. So, there is going to be page fault. Okay, there is going to be page fault. We are going to load this page 7 from hard disk to main memory. Okay, next we have page 6. Your CPU want 6th page of process P1. We are getting page fault because page 6 is not present in the main memory. So we have to load this 6th page from hard disk to main memory. Okay. Next, your CPU is requesting for first page of process P1. And this first page is not present in the main memory. I have to swap out one of these pages. Okay, we have to swap out one page out of these 3 pages so that I can load first page of process P1 in main memory. So the question is, which page I should swap out of the main memory? Okay, so if you look at, we are trying to check the future. Okay, if you look at this 7th page present in the main memory, we need it in a future. Okay, and this 7th page is very close to first page. What does it mean? We need this 7th page in a near future. Okay, next we have 6th page. 6th page we also need in future. So if you are going to swap out either 7th page or 6th page from main memory, then again at a later point of time, you again have to load these 2 pages into the main memory. Okay, we want to reduce the transferring of data from hard disk to main memory. Okay, because if you do lots of transferring of data from hard disk to main memory, lot of time is going to be wasted. Okay, so these 2 pages required in the future. So I am not going to replace or I am not going to swap out all of these 2 pages. Okay, if you look at 4, this 4th page, this 4th page is not required in the future. We don't need this 4th page in the future. Okay, this 4th page has already been executed by the CPU. Now CPU doesn't want this page anymore. So what we are going to do? We are going to swap out this 4th page from the main memory because your CPU is never going to request for this page in the future. Okay, so what I am going to do? I am now going to load this first page in the main memory. Okay, I am loading page 1 of process P1 in the main memory. Next, we have 7th page. Your CPU want to get page 7 and this 7th page is also present in the main memory. So we don't want to swap out this page from main memory. Okay, next we have a 6th page. This 6th page is also present in the main memory. We don't need to load this page again into the main memory. This 6th page is also present in the main memory. Next we have first page. Your CPU is requesting for first page. It is also present in the main memory. Okay, so we will give this page to CPU. Next we have second page. Your CPU want to get second page. Your CPU is requesting for second page. But we don't have second page present in the main memory. So what we have to do? We have to swap out one page out of these 3 pages from main memory. Okay, we have to push out one page out of these 3 pages from main memory so that I can load second page into the main memory. Okay, so the question is which page to swap out? If you look at in the future, we need 7th page. In future, out of all these 3 pages, 7th page is needed in the future. Okay, if you now swap out, if you now push out this page from main memory, in the future again, you have to transfer this page again from hard disk to main memory. So, we want to avoid the wastage of time. So, I am not going to swap out this 7th page because CPU is going to request this page in the future. Okay. So, this first and 6th page. But this first and 6th page is not required anymore by the CPU. Okay. So, you swap out any page out of these 2 pages. Okay. So that we can load page 2 in the main memory. So let's suppose I am swapping out page 6 from main memory. Okay. And I am loading second page in the main memory. Okay. Next, your CPU is requesting for page number 7. And this 7th page number is present in the main memory. Okay. Next, your CPU is requesting for page number 2. Okay. Your CPU is requesting for page number 2. It is already present in the main memory. Okay. So, how many page faults we have in total? Total number of page faults in optimal page replacement algorithm is actually 5. Okay. We have total 5 page faults. Okay. We discussed the same example in first come first serve and least recently used. In both these algorithms, we got 6 page fault. But this optimal page replacement algorithm is most effective algorithm. In this optimal page replacement algorithm, we are getting 5 page faults. Why it is so? Because in optimal page replacement algorithm, we are trying to predict the future. Okay, we are trying to know that which pages are required in the future. If you get to know that some page is required in the future, you don't swap out that page if that page is required in the near future. Okay, because if you are now swapping out that page from main memory, you again have to load that page in the main memory. So time is going to be wasted. Okay, but this optimal page replacement algorithm is not practically possible. Okay, you don't have executed your program. Without executing your program, you cannot determine the future, that which instruction your program is going to be needed in future. Okay, when you start executing your program, only then you get to know that in future I need this instruction. But without executing the program, you cannot predict the instruction you will be requiring in the future. Okay, so optimal page replacement algorithm is not practically in use. But this first come first serve algorithm and least recently used algorithm, page replacement algorithm, might practically possible. Okay, both these algorithms are practically in use. Okay, because in optimal page replacement algorithm, it is very difficult to determine the future without executing your program. Okay, if you are, let's suppose, executing this instruction, if you are providing your CPU this page, okay, you don't know which next page you will be required. Okay, so that's why optimal page replacement algorithm is not used in practical, but it is going to give you the best performance out of all of the page replacement algorithm. Okay, so I hope that you are clear with optimal page replacement algorithm. If you have any query, I have mentioned my email ID in the description box. You can contact me on that email ID. If you like my video, please like, share and subscribe my channel.